Alright everybody, welcome back to another video. In this lesson, we're going to be discussing how to set up a database for your Godot 4 MMO using Golang for the backend. And here's just a quick demo of what we'll be achieving by the end of this lesson. We're going to have a way to open up our game, connect to the server, and then it's going to transition us into a connected state where we can then choose a option of either logging in or registering. So I can go ahead and register an account and it'll tell me registration successful, and then I can maybe try to go ahead and log in. So if I type my password wrong, it'll give me an error, but if I type it correctly, I'll be proceeded to the game. Maybe my friend wants to register as well, but he doesn't know that I've taken my preferred username already. So he tries to log in with this username as well, but he gets an error saying that the user already exists. So if he just changes his username slightly, maybe he tries to log in, but the user doesn't exist yet, he has to register first and then log in. And then both of these players are into the chat room. We have sort of broken our chat room functionality for now, but we'll be restoring that in the very beginning of the next episode. So stay tuned. Last time we just finished introducing a state machine system to better organize our code, and in this part we're going to be setting up a SQLite database, and we're going to be installing a tool called sqlc in order to compile some raw SQL code that we're going to be using to drive queries in our game. The reason we're not using an ORM, or an Object-Relational Mapping library, is that due to the philosophy of Go of keeping things simple instead of complex, we're just going to be going with writing our own SQL queries, which is something that many of you might already know how to do, but if not, we'll be keeping the queries very simple, and SQL is very Googleable. You can easily find out the information that you need without having to search for a very specific ORM technology, which might always be getting updated and information might be going irrelevant. On the other hand, SQL has been around for decades and it's not likely to change in the future, so writing our own SQL and then using a simple tool to convert those queries into Go code is going to be the best bet for us for our small to medium sized project. And as always, you can come to the GitHub project, come to the releases section and download the code as it was by the end of lesson 4. Otherwise, if you've been following along so far, let's go ahead and get started. First things first, let's go ahead and go into our project directory. Make sure we're in the server folder. So type cd server, just clear my terminal like this. And we're going to go ahead and install the sqlc package by typing go install github.com/sqlcdev sqlc command sqlc at latest. And once that's done, we should be able to go ahead and type sqlc into our terminal, and it should just start working out of the box. If you get an error, just try closing your terminal with this little button here and opening up a new one, and that should fix it. So now we're just going to install another package for our project specifically. This will be what we're going to use to interface an SQLite database with our Go code. So we're going to type go get modern c.org/sqlite. So this is just a pure Go implementation of a SQLite 3 database engine. This just means that we don't need to have a C compiler installed on our system when we deploy it to production. But you may want to consider swapping out for a different one, but for our purposes, this is going to be just fine. So we're going to create a new folder inside our server/internal/server directory. And we're going to call it db for database. Inside the db folder, we're going to create another folder called config. And then inside the config folder, we're going to create a file called sqlc.yml. This is going to define where we want to look for queries and where we want to output them as Go code. So this is kind of just telling the sqlc tool what we want it to do. So this has some sort of syntax associated with it. I'm just going to copy the config file from the MMO part 5 post on my blog. So I'll just come over to here and just click copy and then just paste it right there. So I'll save that. So this is basically just telling sqlc to look for a file called queries.sql and another file called schema.sql, and then output generated Go code one level up and in a package called db. So this will make more sense once we start defining our schema. So let's go ahead and do that now. We're going to create another file inside the config directory called schema.sql. And this is where we're going to be defining our first database table. So we're going to type create table, if not exists, users. So this is just going to go ahead and create a users table if one doesn't already exist. And here we're just going to define the columns for our users table. So we're going to have an ID, which will be an integer, and a primary key, which will auto increment. We're going to have a username, which is going to be a string, which is not allowed to be null, and it has to be unique. And we're also going to have a password hash, which is just going to be a string, which is not allowed to be null. So these are the 3 columns in our users table. And this SQL is just going to create the table with these columns and these data types. So the ID column is going to increment as we insert rows into this table. So this will just happen automatically. We can then insert usernames and hashes of passwords. So we don't want to be storing the passwords in plain text, since that's a security risk. Instead, we'll be hashing the passwords with an algorithm that we're going to need to install another library for, but then stick that hashed password into the database. So let's save the schema.sql, and let's create another file inside the config folder called queries.sql. And sqlc wants us to type these comments starting with a double hyphen, and then the type name, a colon, and then a space. And then this will be the name of the function. So we're going to create one called getUserByUsername, and then a space, a colon, and then how many rows does this thing return? So we just want it to return 1 row. And then the query itself is going to be select all from users where username equals, and then we're going to be using this question mark character to mean this is going to be a placeholder for whatever the user puts into this function. And we'll just say limit 1. So we're only returning the first row, even though username is a unique column anyway. We're just going to put this limit 1 here just in case. So when we run the sqlc tool, it's going to take our queries and it's going to output Go code. And we're eventually going to have a function called getUserByUsername as part of our generated Go code. Let's specify another query called createUser. This is going to also return 1 row. It's going to return the row of the user that it created. And let's just go ahead and say insert into users. We'll put username and password hash. These are the columns that we're going to be expecting. Values, question mark, question mark. These are going to be the 2 parameters that we supply into the function. And we'll just say returning star, signifying that we're going to return the row that we inserted at the end of this function. So we can save this file now, and we can actually go ahead and try generating this file using sqlc. So make sure you are in the root directory of the project. So if you're already in the server subdirectory, we want to come back up by typing cd and then 2 dots like this. So now we should just be in the project root. I'm going to clear this. And now we're just going to type sqlc generate -f, and then we're going to supply the config file. So our config file is located in server/internal/server/db/config/sqlc.yml. So when we run this, we should see no errors, but we should also see a bunch of stuff generated inside the DB folder. So if I just collapse this config folder so we can see it a little bit better, we have a new file called db.go, and this is just going to be some stuff we don't need to worry about yet. We're also going to have models.go. So this is going to be a bunch of structs representing rows in our tables. And then here are our queries. So these are the functions that we can use in our code to create a user and to also get a user by username. So we shouldn't be editing any of these files, but it's nice to know what is inside them and to know that we can actually use them. So I'm just going to close these. So now that we have the means to use tables in a database, it would be good to actually go ahead and create a database now. So we're going to come into our hub.go file, which is inside internal server, and it's just here. And first of all, we're going to embed the SQL required to generate our schema. So let's come up to the top here, and we're going to be using a package called embed. So let's import that. We're just going to type an underscore and then embed, because if we don't type the underscore, Go is not going to recognize that we're actually using the library just because of how it works. It's kind of a very special library because you use comments to actually achieve some sort of functionality. So I'm going to type // no space, go, embed, db/config/schema.sql. So when I type this is actually going to achieve something. It's going to put the value of whatever's in this file into the string variable that I declare on the very next line. So on the very next line, I'm going to type var schema gen SQL string. And what this does is it's going to allow schema gen SQL to take on the value of what's in this file. And if I didn't put the underscore here, Go is going to think that I'm not using this package because it's sort of hidden the way that it's being used. And if I save the file, it's going to go ahead and get rid of the import. So that's why we just put the underscore there. So with this schema gen SQL string, what we can do is we can create a database pool, and then we can run the SQL in this variable on that database in order to generate the schema. And we're going to do that when the server starts up. So we're going to need to define a connection pool in the hub struct. So let's come down here to where we're defining the hub, and let's just put that here at the end. And we're going to have a pointer to a sql.db. And as we type that, it's going to automatically know that we want to use the database/SQL DB. And inside the constructor for our hub, we are just going to provide an initial value for that DB for the database pool. So we're just going to restructure things here a little bit. We're going to declare DB pool, and we're also going to capture a potential error from the sql.open function. We're going to specify we want an SQLite database, and we're just going to call it db.sqlite. So this is the output file name, and by default, that's going to go in the same directory as our executable, which is just in our server/cmd folder. We're just going to check for errors here now. We're just going to log a fatal error if we can't open the database pool. And then we're going to go ahead and return the hub with everything as it were, except now we're going to have a DB pool. So the idea is that each client interfacer is going to have its own database transaction context. So this connection pool is going to be able to create a bunch of different connections that each of our clients are allowed to use, and they're going to have an associated context. So basically, we're going to want to create a wrapper for those two things, the connection and the context, and we're going to give that to each of our client interfaces. So let's go ahead and create a new struct up here. We're just going to call it DB transaction, or DBTX for short. We're going to give it a context.context from the standard library just here. And we're also going to give it a pointer to our db.queries, which is the code that we generated at the beginning of the video. So that lives in this package here. Now let's create a quick constructor for a new database transaction. So we're going to go new dbtx. We're not going to pass in any parameters. It's going to return a pointer to a database transaction, and we're going to return the address of a new database transaction struct with the context of just like a basic background context, although we can come back to this later. And the queries is going to be db.new, and then we supply the connection pool here. And this is actually going to be a method on the hub. All right. Now let's add a new method to our client interfacer to allow for the client to grab a transaction instance. So let's come down here and let's put it maybe anywhere we like. I'll put it here. We're just going to call the method dbtx, and it's going to be of type dbtx. And we should immediately start to see the compiler complaining that WebSocket.go no longer satisfies the client interface. So let's go ahead and implement the new method. I'll just put it before the close method. So it's going to return a pointer to a server.dbtx struct. And I'm going to type return c.dbtx, which is something that doesn't exist yet. So let's go ahead and put that in. So we're going to come all the way up to the WebSocket client struct, and we're going to add on a dbtx member. And now in the constructor, we can define the database transaction context inside these parameters here using the hub's new dbtx method. So that's made all of the errors go away. So now we can go back to the hub and we can finally create the database and generate the schema. So let's come to the run method. And just before we start awaiting client registrations, let's just print initializing database. And then we're going to try running the SQL that we saved in the gen SQL variable. So we're going to run h.dbpool.exec context. So this will run the query with the given context. So we'll just use another context.background. And then this is where we use our schema gen SQL string. So this is going to contain all of the SQL that we want to run. And notice how this function returns a result as well as an error. So we don't really care about the result. but we do care if there was an error. So we're just going to try and capture that. And we're going to check to see if the error was not nil. We'll just go ahead and log a fatal error. Cool. So if we go ahead and run the server now, we should see a db.sqlite file gets generated alongside our main.go. And we can see we have an error. So unknown driver SQLite. So it turns out we actually need to add an import to our top of the file. And this will be the package that we installed before from, from this command here. We just forgot to import this. So this is another sort of package that doesn't do anything if you're looking at purely the code, but it somehow injects its own logic into the script. So I think it's when we write SQLite here, it's somehow invoking that package. So we just need to make sure that we've imported it, which is why we need to put the underscore here as well, because the Go compiler is not going to recognize that we're using it. So it'll try to remove the import. But let's try to run that again. And we see initializing database and awaiting client registrations. And then we see our db.sqlite database inside the CMD folder. So we've successfully created and initialized our database. So how do we actually use our database? Let's go ahead and see if we can create a new user in the database using our code. So we're going to come into the connected.go state file. So let's go to internal server states, connected.go. And just in the onEnter method, we're going to see if we can actually create a new user, just sort of like as a test. So we're going to grab our client's DB context object. So we're going to type c.client.dbtx.queries.create user. So this is the function that we generated using our SQL. You can see that it takes in a context and some create user params, and it also returns a user from our models file, as well as an error. So let's supply a context. We're just going to use the c.client.dbtx.ctx. This is just the background context that we've packaged inside this object for our client. And we're going to go ahead and for the params, this is going to live inside our db package that we generated. So we're going to type db.createUserParams from server internal server/db. And if I press Control space, you can see it's expecting a password hash and a username. So let's set the username to test, and password hash will also be test. Let's say test123, just so we can see the difference. And we'll close off that function bracket. Just fix this little typo there. So it's a lowercase b. And because this thing outputs a user and an error, we're just going to say user error equals, and we'll just check for an error. We'll just use our logger to print a statement. Otherwise, we'll actually print the created user. So if we save that and rerun our server, we see awaiting client registrations. So this code isn't actually going to run until we connect with the client. So let's open up our Godot project. And we'll just connect to the server by pressing the run button. And we'll just keep an eye on this output here. So you can see it says new client connected, switching to connected state. And here it's actually printing the user that we've created in the database. So it's got a username, it's got an ID of 1, a username of test, and a password hash of test123, just like what we specified in the create user params. And another way of just browsing the database is by installing an extension on VS Code. I'm just going to search for SQLite 3. I'm just going to install this one called SQLite. And we can go ahead and press Ctrl-Shift-P and search for SQLite. We're going to choose the one called New Query. And here we can just type any SQL that we want and run it on our database. So I'm going to type select all from users, and I'm just going to press Ctrl-Shift-Q. It'll ask us which database we want to run it on, and automatically it suggests our db.sqlite file. So I'm going to select that one. And you can see here the output of our query. So here we can also see the row that we created. So maybe if I go ahead and create another one, maybe I'll call it Kristen, my password hash, rerun the server, rerun the client, and I'm just going to rerun this query. So I'm just going to press Ctrl-Shift-Q again. And I can see now there are 2 rows inside the database. So this is a really great extension for debugging your data or just for browsing what kind of data you have in your tables. And it's also a good way of prototyping your queries before you put them inside your queries.sql file. So if I wanted to create a function to grab a user by username, I can test it out by typing like select star from users, where username equals Tristan. I can run that and you can see how this works, just sort of for prototyping. So I'm going to go ahead and close these windows here, and we're not going to need this anymore. So I'm just going to get rid of it. So now that we have proof that this works, we can go ahead and use our time to try to create an authentication system. In order to send an authentication packet, we're going to need to come back to this file that we haven't touched since I think maybe the first part or the second part. It's under the shared folder called packets.proto. And we're actually going to create a new kind of packet called a login request packet. We can also create a register request packet while we're at it. And then we're going to create some standard response packets that the server can send back to the client. So just underneath these messages that we've already defined, we're going to create the ones that I just mentioned. Login request message is going to contain a username and also a password. So this is going to be an actual password, not a hash of a password, because the client is not going to know the hashing algorithm. So it's just going to send the password over plain text. And we're going to get to encryption in transit towards the end of this series. So don't worry too much about the security of this. It's all going to make sense by the end. Before we deploy, we're going to make sure that this is all encrypted. We're going to have a register request message, which is going to have the same payload, but the intention is that this is going to be for registering a new user. And we're going to define 2 kinds of responses. One is just going to be called an OK response, and then the other is going to be called a deny response. And the OK response message is not going to have any payload, but the deny response is going to have a string called reason. And this will just be a quick description of why the request was denied. So we've defined these 4 new types of messages. Let's go ahead and allow our packet to hold those messages. So I'm just going to let Copilot do the work here. And I'm going to go ahead and press Control S, which, because I have the VS Code proto extension enabled, it's actually gone ahead and recompiled my packets. So inside this packets.pb.go file, I can see a bunch of changes. And this is the Go code representing those packets that I've just defined. But if you don't have the extension, or if it didn't work, you can always come and run this command here from the root of your project. So that will just do the same thing. Because we've gone ahead and defined some new packets that the server could potentially be sending, i.e. these response types of packets, we're going to go and create some helper functions to just make it easier to create these packets, because it can be a bit of a mouthful, as you might have seen in the first lesson. So we're going to open up our old friend util.go under pkg/packets, and we're going to define 2 new functions. One is going to be new OK response, and it's going to take no parameters. And it's just going to return a packet underscore OK response with a message of an OK response message. And we're just going to do the same thing for the deny response. We're going to give it a string of reason. And there we go. We'll just let Copilot do the work for us on that one. So now it should be pretty easy for us to create these types of packets. We are also going to need to regenerate the Go code for the client. So come back to Godot editor, and remember we have this Godot buff tab next to our file system tab. If you don't have this, you'll need to make sure you watch the first video where we installed this plugin. And we're just going to select the input protobuf file. So we're going to go upper level to the shared folder and then packets.proto. Just select OK. And our output GD script file is just going to be packets.gd. And we're going to go ahead and press compile. So now Godot is going to have access to all of these new packets. So before we get started sending these types of packets from the client, we're going to set up the server to actually interpret these packets first, because we're going to need a couple of things. So we're going to cd into the server because we're going to install a new package. We're going to get the bcrypt package, which we're going to be using to hash the passwords. So go ahead and run go get golang.org/x/crypto/bcrypt, and we'll just let that install. And then we're going to come back to our connected state. So under server/states, we're going to open up connected.go. And we're going to start handling a new type of message. We're just going to get rid of this existing logic because this was mostly for a test for the chat room, and we're going to re-implement this down the track anyway. But for now, we want our handle message method to a little bit neater than that. So we're actually going to be using a switch statement. We're going to define a variable called message, which is just going to take the type of the supplied message. And we're going to check to see if it's of type packets.packet underscore login request. We're going to create a handler called handle login request with a sender ID and message as arguments. So we haven't created this handler yet, but we will when we're finished typing the rest of the cases. And the only other case is going to be a packets.packet underscore register request. So let's go ahead and define these two methods. So for the login request handler, the message is going to be of type packets.packet underscore login request. And the first thing we're going to check is we're just going to do a quick sanity check, kind of like an assertion, to make sure that the sender was actually our own client, because we never want to accidentally mess up and start sending these kinds of requests to different clients. It's just going to be a mess. So it's free to just do a quick check here. If sender ID is not equal to our own client's ID, we'll just do a logging statement. Received login request from another client, put the ID in there, and we'll just return in that case. But otherwise, let's go ahead and set the username equal to the messages.login request username. And if they got their username or their password wrong, we want to send them just a generic error message. We don't want to give away too much information. So for instance, if they got the username correct, but the password was wrong, we don't really want to let them know that they got the username correct, because a hacker could use that to their advantage. So I'm going to go ahead and create a variable called generic fail message equals packets.newDeny response. So this is the helper method we put in util.go, and I'm just going to put incorrect username or password. So we're going to get that set up so we can send it if we need to. So now we're going to try to retrieve the user from the database. So we're going to use the client's database transaction context. So user, this is going to be the user row. This is a potential error from c.client.dbtx.queries.get user by username. This is the other function that we defined, and it's expecting a context and a username. So let's supply the default context c.client.dbtx.ctx and the username string from this that we defined up here. And you'll notice that this is getting to be quite cumbersome, having to type this all the time. So I'm actually going to define two new properties of our connected state. One is just going to be queries, and it's going to be a pointer to a database queries object. And the other one is just going to be the database context. dbctx is just going to be a context.context. And that should import the context package for us, as well as the db package. So let's come back down here and we can simplify this code a little bit. So I'm just going to replace this queries with c.queries. And I'm going to replace this context with c.dbctx. And then I'm going to come back up to the set client method. And I'm just going to define c.queries to be the client's dbtx.queries, and c.dbctx is going to be from the client as well. So let's come back down to the method we were working on. So this looks a bit nicer now. Trying to get the user by its username and either return a row or an error. So let's first check to see if there was an error. We're just going to log the error on the server side. We can log the specific error, but when it comes to sending that feedback to the client, we're just going to send the generic error message. And then we're just going to return because there's nothing we can do from here. Otherwise, we are going to try hashing the password that the user supplied when they tried to log in, because we're going to compare that password with what's in the database. So let's use the bcrypt. So when we select this, it's going to go ahead and import the bcrypt package for us. .compare hash and password. And this expects a encoded hashed password slice of bytes. So we're just going to cast our password hash from the database. We're going to cast that as a slice of bytes, and it will automatically encode that for us. And we're going to compare that with the supplied password from the login request. And we also need to cast that to a slice of bytes. And this thing will return an error if there was an issue comparing that one stored in the database with the one that the user is supplying. So we can go ahead and set error equal to that, and then check for this new error. So under this context, an error is going to represent the fact that the user typed their password in wrong. So we can go ahead and log that and send the generic fail message to the client again. But if we've made it this far, it means that the user exists and they got their password correct, so we can allow them to log in. So we're going to send them an OK response packet. And we'll also log something for our own purposes. We'll just say the username and that the fact that they logged in successfully, and we're going to send them socket send packets.new OK response. Okay. One thing that we should really do actually is just convert the username to lowercase before we try to retrieve it from the database, because maybe the user typed a capital letter for their username and we don't want to discriminate against that. So let's just, instead of passing in the username as it is, we're just going to type strings.toLower and then username. And when we press Ctrl S, it should import the strings package for us. We've got our login handler all good to go. Let's now define the registration handler. So handle register request with a sender ID and a message of type packet _ register request. And again, we're just going to do a quick sanity check. So I'm just going to copy and paste the sanity check from here, just to make sure that it is our own client sending this kind of request. So we're just going to grab the username like we did before. This time it's coming from the register request packet. Now let's go ahead and see if this username already exists. And if it does, we'll have to send a deny response because we don't want to allow a user to register the same user twice. So let's check if we can find this user already in the database. And here we're converting the username to lowercase as well before we check in the database, because all of our database usernames are going to be lowercase. And here we just want to check if, and we're just going to ignore the result, but we want to check to see if there was an error. Well, we actually want to check to see if there was not an error, because there will be an error if the user doesn't exist with that username, but we want to check to see if the opposite is true. So let's go ahead and log user already exists, and we'll send a deny response saying that the user already exists for this username. If we've made it this far, we're going to go and specify another generic failure message, and we'll just say that there was a internal server error or something like that. And this is just going to be our catch-all deny response for anything that's going to go wrong from here on out. The only thing that the user cares about that could have gone wrong at this point was the fact that the user already exists. Everything that could happen from here on out, we're not really sure, but we're just going to tell the client that there was an internal server error. So, and then we might as well also say, please try again later. So we're going to go and try to hash the password. So password hash equals, and there also might be an error from bcrypt here. So we're going to go bcrypt.generate from password, and it expects the password as bytes. So let's go ahead and cast that as a slice of bytes. Message.registerRequest.password, and we need to supply a cost function, which is just bcrypt has some sort of cost functions where it's kind of like if you try to spam hashing things, it's going to make the server work for that. This is just to avoid some sorts of brute force attacks. So we're just going to type bcrypt.defaultCost. And now we can check to see if this error was not nil. We can go ahead and say that there was a failure hashing the password, and we can send the generic fail message to the client. If there was no problem hashing the password, we're going to see if we can create the user in the database. So we're just going to say there might be an error from this, but let's go c.queries.create user, c.db context, and we're going to use the db.create user params again here. We're going to supply the username as the strings.toLower of our supplied username, and the password hash is just going to be a string of our password hash, which is because bcrypt supplies it as a slice of bytes. That's why we just need to cast it to a string here before we insert it into the database. And then we can finally check to see if there was an error putting this row into the database. We're just going to say failed to create user and send the generic error message back to the client. And finally, if they got this far with no errors, we can send an OK response. So the register logic is a little bit more involved than the login logic. And on top of that, we might want to sort of validate the password as well. So like we don't want to let someone register with an empty username or a password that is too simple or a username that's too long. So we can specify a function to handle the validation logic on the username, and we can let that return an error if there was an issue with the username. So here, for instance, we could type error equals validate username, and we can pass in the username. And then just down here, we can create that function. So maybe let's see if the length of the username was, if the username was nothing, then we can just return errors.new empty. Or another example is if the length of the username was too long, we can just say too long. And another thing too is like if the username just contained spaces, or if there were spaces at the beginning or end, we can also say that we don't want that. So if username is not equal to strings.trim space username, we can just say leading or trailing white space. And you can add as many checks here as you want, but in the end, if it gets this far, we're just going to return nil as the error. And we'll go ahead and let Go import the errors package. And this will be a good way of validating the username. So up here where we've specified the error after validating the username, we can check to see if that's not nil. And if it is, we can just say invalid username, print the error message, and then send a invalid username response to the client. And we might actually want to specify the reason so that the client knows why their username was rejected. So we can go ahead and say reason equals formatted string invalid username, and then give the error message. So actually maybe just to make this cleaner, we'll just print the reason using our logger, and then the deny response reason can also be that reason there. And then we'll return in that case. Oh, and I'll just use print line, not formatting anything. So in this method, we are simply just doing a quick sanity check to make sure it came from us. And then we're going to grab the username and perform some validation on it. And that validation is up to us. But here's an example function that you might want. And then we're just making sure that the username is valid. If not, we'll send the feedback to the client and return. And then we're going to check to see if the username already exists in the database when they're trying to register. If so, send the feedback to the client and return. Everything from here on out is going to be some sort of server error, so we'll set up a generic failure message. If there was an error hashing the password, we'll send the fail message. If there was an error inserting the user into the database, we'll send the fail message. Finally, if the user got this far, we can assume that they've registered successfully and send them an OK response. So that was quite a lot. So now it's time to go to the client and build a login screen. So we'll open up Godot. We're going to go ahead and create a new state called connected. So under states, create a new folder called connected. And then under states/connected, we're going to create a new scene called connected.tscn. And it's going to be a node scene. Come to the 2D view. Make sure you've got your connected scene open. And we're going to go ahead and set up a few nodes underneath the connected node. So the first one is going to be a canvas layer. And we're just going to call that UI. Under the UI node, we're going to create another node, which is going to be a VBox container. We're going to set the VBox container preset to just take up full rect. So it's going to take up the whole viewport. Inside the VBox container, we're going to create a line edit called username. And we're going to create another line edit called password. Underneath that, still inside the VBox container, we're going to add a HBox container. And inside the HBox container, we're going to add two buttons. One will be called login button, and the other one will be called register button. The login button will have a text of login, and the register button will say register. At the end of all this, so the final node in the VBox container is going to be a log. This is our custom log object, and we're going to give it a minimum height. So under layout, custom minimum size Y value is going to be maybe 200. So maybe I don't like how this looks. Maybe it's a bit too wide. So I'm actually going to change the VBox containers preset to vCenter wide. And I'm going to set the custom minimum size X value under layout to 300 pixels, or maybe 450. Yeah, I think that looks pretty good. So it doesn't look the nicest, but I think it'll get the job done for now. We can always come back to this to make it look better later. But let's go ahead and get some logic in there by attaching a script to our connected root node. So right click the connected node and click attach script, and we'll just leave the default value. So we're going to need a reference to our packets, and we're just going to drop in all of these. So I'm going to drag, hold control, and then release. So we're going to need the username, the password, the 2 buttons, and the log. And I'm just going to add underscores to each of these just to signify that these are private to this script. And I'm just going to call this username field and password field just to make it clear. I'm going to go ahead and define the ready function. We're just going to connect the packet received signal to our handler, just like we are with the other states. And we'll just go ahead and create that function. We'll just be empty for now. We're also going to have a connection closed signal handler. Connection closed.connect on WebSocket connection closed. And we can just copy and paste the same handler that we have for our other states. It's just going to log an error console. Let's go ahead and connect our login buttons as well. Pressed signal is going to be connected to on login button pressed. And we'll do the same for the register button. So now that we've got all of our signals connected to handlers, let's go ahead and define this functionality. So on the packet received function, we're going to go ahead and get the sender ID as usual. And we're just going to check to see if there's a deny response or an OK response, because those are the only 2 types of packets we're expecting in this connected state. And we're just going to log the reason. We're going to log that as an error. Otherwise, if the packet has a OK response, we're going to have to decide what we want to do when we receive an OK response, because it could be either an OK response saying it's OK for us to log in, or it could be something telling us it's OK to register. So depending on which one it was, we're just going to go and set up a custom callback, and we're going to put it up here. And this is going to be called action on OK received, and it's going to be a callable, which means it's going to be a function. This is just going to be a named function variable. And when we receive an OK response, we're just going to go ahead and call that. All right. So why did I type clear? Has OK response. And then we're going to go ahead and call the action on OK callback. And that doesn't mean anything right now, but it will once we define this variable. All right. So when we press the login button, we're going to want to send a login packet and then set our action on OK received function to be just setting the state to the in-game state. So let's go ahead and do that. Going to create a packet the same way that we always have been. And then we're going to create the login request message. So packet.new login request. And then we'll set the username and password on that message. Set username will be the username field's text. So just whatever was inside the username line edit. And we'll do something similar for the password. We'll just use the password field's text. Then we'll go ahead and use our WebSocket.send function. We'll supply the packet that we just created, and then set the on OK received callback equal to this function. If we receive an OK response, we're going to go ahead and say game manager.set state, game manager.state.ingame. Okay, so I'm actually going to copy this, and I'm just going to paste it into the registration button pressed handler, because it's going to look very similar. We just want to make sure we are creating a register request message, setting the username and password, and sending it off. When we get an OK message back, we're going to log a success message. Okay, so that's all good. We just want to register this new state with our game manager. So open up gamemanager.gd. And we're just going to put that in between the entered and in-game states. Not that the order matters, but it just sort of makes logical sense in terms of the progression. And we're just going to drop in the path to our connected scene, just like that. And we just need to add the connected keyword to our state enum. We can save our game manager script now. And now inside our entered script, so this is the script for our entered state. Instead of going straight to the in-game state, we're going to go to the connected state. So this makes more sense. Instead of taking us straight to the game, it's going to take us to the login screen when we actually successfully connect. So with all that done, if we run the server and open up Godot and press run on the client, we instantly see the login screen that we created. So we've already been through the entered state, we've connected to the server, and then it's passed us into the connected state where we see the login form. So if I go ahead and type something that's not in the database and try to click login, you can see on the server logs, that first of all, I was switched to the connected state. Second of all, I tried to log in, error getting by username, no rows in results set. And that was conveyed back to us through a deny packet. Now, if I try to register, I'm actually getting an error message saying that the username already exists, which doesn't make any sense. I think I might have got the logic backwards. Let's go ahead and look for this. Yeah, I think I had a feeling I might have got this wrong. So when we try to get the user by username and it's going to return an error if the user doesn't exist, we want to make sure that that error is nil, because if the error doesn't exist, yeah, that's a good thing. That means that we can go ahead and actually proceed. But if the error was nil, meaning that the user did exist, that's when we would want to send this deny. So it's a little confusing. Thanks for bearing with me. I'm just going to restart the server and I'm going to restart the client and we'll try registering again like that. So I'm going to type Tristan. Actually, I think that user might already exist, so I'll just type Tristan1, password of 123, click register, and you can see there that the user didn't already exist, so I get sent an OK message. Now, if I try to log in with my new user, I get taken to the game state. If I get my username correct but my password wrong, I should also get a deny. So let's type 1234, and I get an incorrect username. So we can actually see what the hashed passwords look like in the database as well. So I'm going to press Ctrl-Shift-P, SQLite, new query, and I can do select star from users and press Ctrl-Shift-Q. So these were the two test users that we inserted into the database before, but this is the first real user that was actually inserted by our app. And you can see that this is the hashed password that we generated using bcrypt. If somebody got their hands on our database file and tried looking inside for passwords, this is all they're going to get. And there's no way they're going to be able to reverse engineer that hashed password into what the user originally entered, because the hashing algorithm is designed to be like a one-way street. It's easy to take a plain text string and turn it into a password that's been hashed, but it's almost impossible to take a hash password and run it through the algorithm in reverse. So that's it for the end of this video. If you've made it this far, congratulations, because this is pretty much all of the groundwork done for this project, and the rest of the project from here on out is going to be focused purely on game logic, business logic, and that's where all the fun stuff is going to be. So we've actually successfully made it to our first milestone for this project, which is just to get a basic chat server up and running where users can log in and register. And the next milestone is going to be actually completing our game, which is what we're going to be doing in the next 5 parts or so. We've done a lot to get here. We set up the project, we worked protocol buffers, we created a state machine and database connections and an authentication system. So it's a lot of work, but here we are and we're doing great. In the next part, we'll be transitioning into the real gameplay logic. So stay tuned for the next episode. And as always, don't hesitate to join the Discord if you are having any issues. We'll be happy to help you out. So without any further ado, I'll see you in the next part.